Hey guys, this is Tuesday, December 10th, and this question comes from the parking lot from fifth block today. Someone in fifth block asked about this, about the linear function section of the finals review problems here. So this specifically linear functions dealing with slope, because we dealt with slope a lot this semester. So this question specifically has to do with this question down here. Question 9, problem number 9. And I think what makes this hard is that this all of a sudden, after doing several problems up here, right, dealing with the mathematical definition of slope, all of a sudden it changed to a word problem, okay? So I've moved that problem over here. This is one we ultimately want to talk about. Okay, so this one here, we got to read into this word problem and figure out what they're talking about for slope. But right before that, we have several problems here where really this wasn't too hard. We just had to mathematically determine what the slope is based on equations, based on graphs, right? Finally, based on tables and based on having points, okay? So it was easy for us to tell that the slope is 2 here, right? Next to the x variable and y equals, well, b plus mx form, okay? Easy to see that it's undefined here, right? This would be a vertical line here if x equals -5. And also, too, this one here, easy for us to change this, right? Change this to y equals mx plus b form and determine our slope here would have to be -2. Okay, so where this changes, right, going from equations, going from graphs, going to tables right now, is all of a sudden we have a situation, okay? So when we have a situation, right, slope, we need to think of slope as our change in that situation or our rate of change. Remember, our rate of change is still going to be the change in the dependent variable divided by the change in the independent variable, right? Or change in y over change in x. Okay, so in this situation, we got to think about what our independent and dependent variables are. Well, Sam started working at Boba Guys 3 weeks ago. He had $20 when he started working, and now he has $110. He has not spent any money. Okay, so one thing that could help us find the rate of change in this problem is also to talk about what's not the rate of change, meaning, is there a starting number in here, okay? And first of all, this $20, right, this is our starting number. So we don't care a ton about that right now, but it's gonna help us come up with our rate of change, okay? So here, Sam started working at Boba Guys 3 weeks ago. He had $20 when he started, then 3 weeks later, right, 3 weeks later, he had $110, okay? So this is 3 weeks later. Okay, so then we gotta think to ourselves, right, what's the rate of change here? Well, we have 3 weeks. Weeks, of course, is our dependent variable. Actually, it's our independent variable, right? Because time is changing, and the amount of money he gets is gonna be the dependent variable, because that depends on time, okay? So the question is, how much money did he make? Well, he had $110, okay, after 3 weeks, and then, right, he started with $20, okay? And, right, so our change in the dependent variable, the change about how much money he made, was $90, okay? Meanwhile, we gotta think about how our independent variable changed. Well, at $110, that was 3 weeks into our situation, okay? 3 weeks after week 0, right? At time 0, he had $20. So very simple here for our independent variable. We just got to subtract 0 weeks from 3 weeks, right? So we made $90 over the course of 3 weeks. Okay, we can simplify this, right? 3 goes into 90, goes into 90 30 times. So we bring down our dollar sign, and we have $30 for every 1 week would be the way we would simplify that fraction right there. And that is our answer to number 9.